What? Yeah, I'm Zach Tellman. I work for Runa. I'm here to talk to you about Aleph, which is, among other things, a web server. This talk is going to be an abridged version of the wiki that is available on the GitHub repository. If you find it interesting, I encourage you to go actually check that out. So, Aleph, it speaks many protocols. It has client and server support for HTTP, server only for WebSockets, TCP, serialized Java objects, more will be coming. The unifying interface for this is what is called a channel. And a channel is an event-driven queue. It is not immutable. Once a message passes through a channel, it is gone. And the idea is that this is meant to be sort of an event-driven equivalent of seeks. You want to have one sort of abstraction. You want to have many useful functions that operate on it. When you have a channel, you create it with just the call to channel. You can enqueue messages into the channel. And then, since there are no consumers currently, it just sits there. When you register a callback with receive, it will go ahead and pass the first message into that callback. Note that it is printing out something. It is not returning any value, rather it's returning true to say that the callback was successfully registered. When you have multiple callbacks registered on an empty channel, they will both receive the next message. So notice that you register 2 callbacks, you enqueue 1 message, they both get that message. Receive all is a just permanent callback. It will go ahead and it will receive all messages that pass through there. You go ahead and have a channel which is initialized with 2 messages. You then register a callback. It will receive both of those messages immediately. When you enqueue a 3rd message, it will also receive that. I'll just point out that enqueue and receive all is basically just publish, subscribe. You can have many listeners. Messages can multiply safely. Immutability helps a lot here. Channels are unidirectional, which means that since TCP and many other things are bidirectional, you have sort of a problem of keeping track of which one is which, right? If you just have 2 channels and you mix them up, all of a sudden it's sort of chaos. So channel pair will give you a pair of channels where a message enqueued into one can be received by the other and vice versa. Basically it gives you 2 endpoints on a bidirectional pipe. For this reason, an echo server is very simple. You go ahead and receive all messages from the channel and immediately enqueue it back into the channel. This is a very common pattern. So there is a function that sets this up called siphon. So you siphon the channel back into the channel, and everything, any sort of bidirectional sort of protocol, basically this just works because the messages are whatever is the proper thing for that protocol. So now that I've powered on through that, I'm going to talk about Tom Fallhaber's presentation, where he was talking about polling for changes, where you're doing a long poll and you want to be able to get back the information immediately if it's fresh, but otherwise you want to just hang there and wait for the new information and return immediately once it's there. And I'm going to spend more time on this. I apologize if that was all too fast. Again, please visit the wiki if you have sort of questions or talk to me later. So, we start with 2 things. One is a ref, which has the latest state, which is initialized with nil. And you have a channel through which the change list, since this is a source control thing, will flow. We have a receive all callback, which will receive every change list as it comes through, and it will go ahead and update the ref. This last one is a little bit more complicated. This is a web request handler. And unlike Ring, where you have just a pure function, instead, you are given a channel into which you can enqueue your response. So we assume that in this case, we're getting some sort of JSON that's turned into a hash. So we go ahead and we get the last serial number from the request. We then go ahead and we, within a transaction, check whether or not the state is later, more recent, than the one that was passed in with the request. If so, we create a channel that just contains that state. Otherwise, we do a take star on the channel, which basically is just like take, except it's asynchronous. And then we return this channel, and we go ahead and we just siphon that back into the response. So either that will be immediate, and notice that we're also doing a map star, which is the same as map, except it's event-driven. And we just go ahead and turn that into the response, and that will go ahead and just magically work. And I'm done. I'm out.